Pandas exercises. Pandas is the main Python library to analyze tabular data, such as Excel files. In this video, you will learn Pandas from scratch by completing 16 progressively challenging exercises. If you complete these exercises, you will be comfortable doing data manipulation using Pandas. So, prepare your notebooks and let's go. Exercise 1. Reading data from a CSV file. Let's create a small data frame, save it as a CSV file, and read it back. We'll explain data frames, what they are in exercise 7. For now, just think of it as a table. We have some requirements. Let's create a data frame with columns name, age, and height for 3 people. We can choose whatever we want. Let's save it as data.csv without row index equal to false. Let's read the file back with pandas function read CSV and print it. And let's keep the result in a variable called data, which we'll reuse in the next few exercises. To start, let's import the libraries that we need, the packages. Import pandas as a pd pandas. Import numpy as np, and let's put this on. This is the standard way, to be less verbose, to refer to pandas and to numpy. Let's create a simple data frame. CSV equal to PD is the first. When using data frame, it creates a data frame. Okay, let's put what we want here. Let's start with name. We can use then, let's check three names. Let's choose 3 names. Anna. The other can be Peter. Let's another one, John, for example. John. Okay. We need a comma. And then this is a comma. Okay. Don't need another one. We need a comma at the end. Let's go for age 45, height. Let's give some different ages here. 25, 30. And the last one, 28. In terms of height, we can now 1.65, this in meters, 1.75. Let's choose another one, 168. Okay. They are not very tall, but they are average size, probably. We referred to this as the variable data frame underscore CSV, and now let's also data frame CSV to CSV, okay, to save this as a CSV file. To CSV. Let's start with data.csv. We wanted here the index to be false, not to save a column that adds row numbers. We will see what this is. It's probably index false. Usually it's the standard way, because if at least usually I don't think we need the numbers in many fields. We already have the way to refer to each. We already know what is each column. Now we read again the CSV and print to check that everything is alright. Let's check if this is alright. Yes, okay. So we have what we created, the name, the column, the age, and the height. We have the names, the list of names, and the rows with age and the rows with height. If we didn't save, we didn't put index to false. Let's try what would happen. You will have an extra column just with the numbers, and we don't need this. So let's put this again. Exactly. Okay, so this will be the first exercise. Exercise 2. Reading data from a text file. Read the same information as in exercise 1, but from a space delimited plain text file. Okay. Requirements. We will write a text file data.txt containing the columns name, age, and height, one row per person, separated by spaces. We will read it back using Pandas read CSV, using this as the separated for the spaces. This means space, and this means one or more space. We will see. So that any white space is treated as a separator, like when we open CSV files in Excel and then print it. So let's check this. So let's write this file with the with function. Open. We want data.csv. Let's write the file as f. And now let's use the function write to, and what we will write in there, it's the contents that we had on the other file, on the other exercise. Name, age, height. We defined space, lane, height, age, height. We have this. We will separate. This means that we have a new line. This is on one line, and when we put this, comes the next line. $65 is something that we had on the other. Let's now go for Peter, 30 years old, 1.75. And let's go for John, 28, 1.68. Okay. This will create the file. And now let's read the file back. This will write the file. Okay, this is the function of what we will write in there. And this will be read the file with CSV. And how we will separate the white spaces so that this was in the requirement. S plus. Okay, that's it. So this means that the file Here this separates by these spaces. Okay. This means this means white space, and this means one or more white spaces. And it will divide. We'll consider that this is for one column, this is for that column, this is for another column, and so on. Let's print. Um, mm, mm, mm. Exactly. Let's print the file. And that's it. The second exercise, the same as we had above. Okay. On the first one, we have this. Exercise 3. Reading data from an Excel file. We'll save and read the data in Excel format. For this, we'll reuse data frame from exercise 1. Requirements that we have. First, save data to this file without row index. This uses the OpenPy Excel package. If you don't have this package, you can go ahead and install. Second, read the file back with read Excel from Pandas and print it. So let's start. We use this data frame from exercise 1. Again, index false. We don't want to print that first row with row numbers. We'll save a new variable called data Excel, now in Excel format. And we will just print the Excel file. So, there we have it, the same data frame as in exercise 1. Exercise 4. Inspecting a data frame. Before analyzing data, you first need to look at it, and Pandas has quick methods that allows you to preview a data frame and gets the statistical summary, which is the very first thing that you do after loading a file. Okay. The requirements, what will we do? We'll create a data frame with a name, age, and height for 6 people. Since this will take a while, I already did it right here. Okay, 6 people, 6 names, and we have the age for each of them and the height. We will preview the first rows with head, the last rows with tail, and then the shape, which is the number of columns and rows with the shape, the names of the columns, the data types, and we will check with these are properties of the variable of the data set, and these are functions, the info and to describe, which gives us a statistical summary with maximum, minimum, mean, median. So let's start right here. We already have the students head, okay, and you examine. By this you quickly see the columns that it has and the first few rows, and if they are letters, strings, or numbers, and the type of numbers. You can quickly check the end of the data set. This is useful for you to see the number of examples in the data set. Okay, in this case 6, since it starts with 0. We have 5 here. For the properties of the student's variable, you have, for example, shape, which gives you the number of rows and the number of columns. 6 rows, okay, and 6 rows and 3 columns. And let's continue. Which is the next one? Data types. Students, D types, and let's see. You have here the type of variables, strings, integers, floating numbers for the height. Okay. And then you can check students info. You have some of the information that you have been obtaining. Okay. Resume of all the information, 6 entries, the column types, and the data types here. Okay. And I think in the end you can students describe. You have a description, statistical description of the data set with the number of examples, mean, standard deviation of the mean, minimum, maximum, and you have this description for the variables which are numerical or floating point numbers, okay? And that's it for exercise 4. Let's go to exercise 5. Exercise 5. Dates and times. Pandas has a built-in support for working with dates and times, since it was first originally built for the financial industry. And we have here for this exercise some requirements, which is use data range to generate 5 consecutive daily dates starting on 2027, January the 1st, then printing the resulting data range. Afterwards, we build a data frame and pair these dates with the value column, and then we print again. So let's start this. We have the dates data range. We can start, okay. We have here the start, which will be 2027 periods. We want 5, okay. That was what we wanted. And the frequency, we want D, which is daily. And then we print dates. And here we have the dates. Now we have to pair this with create a data frame and pair this with a value column, which could be the temperature, for example, or any other property. These data frame dates, data frame, this can be date, the date, which can be dates, and here we can have the correct. This is more. This is cleaner to write. We can have the value column, and here we have to attribute it ourselves since it is not created. 20, 25, 30, for example. Okay, I think it's fine. I have here the comma. We have to print. And that's it. We wanted the dates that we generated paired with a value column. And that's it. The answer to this exercise. It's this. Let's go to the next one. Exercise 6, series. A series is a one-dimensional labeled array, like a single column with an index. It's like a dictionary, but with ordered values. Requirements. We create a series with the values 1, 2, 4, 1, 2, 3, 4, and the index labels will be A, B, C, D. We will print a series and access in two different ways. At the label B using point lock, and at position 1, for example, using iLock. Okay. And let's go. Let's create a series. With the values that we had there. Index exactly what we want. And let's now print the series that we have. Okay, so this is the index and these are the values for this series. And let's now go to locate the values series with using lock at label B. Okay, this is the value 2 at label B, and series I lock at the position that we want, which is a position 1. We can also locate, which is also, this will be position 0. This is position 1, value 2. So this is the answer to this exercise. Let's go to the next one. Exercise 7, data frame. Until now we have been creating data frames. Now we will take some time to explain them, and this exercise intends to create a data frame to then to be used on the next few exercises. A data frame is a 2D table, like a spreadsheet, where each column is a series. To put it simply, a data frame is a spreadsheet that you can control with code. You get the familiar rows and columns mental model of Excel, plus the speed, repeatability, and power of programming. The requirements. It's to create a data frame which will be used in the next few exercises with a name column, an age column for 3 people, and print a data frame. So we probably, the exercise consolidates what you have been learning until now. Name column. Let's see what we are going to give. And let's call the second. Can be Peter like above. And we have John back also. And these are their ages. Let's modify a bit age to have different values. And again the 28. And after this we print the data frame df. Okay, and this is the data frame we created. So we explained what is a data frame, why is this useful, and now we will go to the next exercise. Exercise 8. Assessing data in a data frame. Here we will practice different ways of selecting columns and rows from the df data frame we created. Requirements. Print a single column, the name column as a series. Filter and print the rows where name equals to Peter. Then we will print the first row using iLock and the row with index label 0 using point lock. Let's start sprint from the data frame. The column name, we print it. Now we will filter and print the rows. Let's see how to do this. Print. We want to print the data frame, df, but within that data frame we want to filter, so inside this data frame we select the name that equals to the name that we want, which is Peter. If you did it like this, okay, it wouldn't work. Okay, it just tells which is false or true. The second one is true. But to really select, you have to filter, you have to do this. This was what you are selecting from this data frame. Let's print here from the df data frame using iLock position 0. We have Anna at the first position, the name and age. And then from the df also the lock with the label 0, which is as expected the same result. This is by number, this is by label, but they have the same labels. And that's it. Okay, the answer to this exercise. Let's go to the next one. Exercise 9. Exercise 9. Extracting information from a data frame. Here we will combine column extraction, Boolean indexing, and single cell access to extract data. Let's use the data frame data from exercise 1. If you don't have it, you can produce it right now in this way. The requirements. You have to extract and print the age column. Then we will use Boolean mask, which means true or false, to select the rows where the age higher than 25 equals to true. And then we will use point lock to print a single cell at row 0 from the column name. And let's start. So if we need, you can produce the data set that we are going to use. And let's proceed. First is print data age. Exactly. We printed the column age. Then we want to filter. Let's first produce an age filter in this way. From data, we select the age higher than 25, exactly, and then we print the data from the data dataset. We filter according to the values that are true for this condition. Exactly. Those that have age is higher than 25, we printed right here. This is 25, so it didn't print. And the last one, lock. Using lock at position 0 and for the column name, which was Anna. We go to the column, we can print, it's easy here, print data from the column name. We see the position 0, which is Anna. Okay, it's right. So this was the answer here to the questions, to these requirements. So this was exercise 9. Let's go to the next exercise. Exercise 10. Handling missing data. Real-world data is rarely complete. Pandas gives you represents missing values as NaNs, not a number, and gives you tools to find, remove, and quickly fill them. Requirements. Let's create a data frame with name, age, height for 4 people, but leaving some missing values for us to handle. We will use isNA to see which cells are missing, and isNA .sum to count the missing values per column. We'll also use dropNA to keep the rows that have no missing values, only the ones that are complete, and fillNA to replace the missing age values with the average age and then print the result. So let's start. We already created the data frame with the missing values to be faster, but you can go ahead and create this. Let's now handle this data set. isNA, and we see the positions with missing values. This one, and this one. Okay. This is not the most efficient for large data sets. We would have most likely to sum. And let's print also this. And now we sum for each column. For the name, 0 missing values, for the age 2 and the height 1. Exactly. Name, no missing values, age 2 missing values, for the height 1. Now the third step is dropping the columns, the rows with missing values. Is NA drop NA. We have to print at the end. We just drop NA. It's enough. Okay. So we kept just the first row, which didn't have any missing values. And now we will fill the missing values with the average age. So for this we'll have to do first calculate the average value, the average age, okay, for the F missing age mean, exactly. Let's create a copy of this. This is a good practice, okay? When you are altering a dataset, create a copy of the dataset for the because you might need to go back, and in this way you have a copy, okay? Here we have little mistake. Okay, we can just already do this, and now really do what we want, which is come right here with age. It's alright, the age. For the age, you go to fill it age, okay, and we fill NA with the average age, and then we print. Exactly. So we altered this column with the average age. Okay, we could do the same for height. And exactly 26.5. And then we printed the whole filled data set. And that's it, the answer to the problem. Here, first we created the data frame, then seeing if we have missing values, where they are, sum the missing values per column, dropping the columns with dropping the rows with missing values, and then in the end calculate the average and fill with the average the age. We could do the same for the height. So that's it for handling missing values. Let's go to the next exercise. Exercise 11. Plotting with pandas. Pandas integrates well with matplotlib, which we learned on the last few videos. So the point plot method works directly on data frames and series. Requirements. We will draw a bar chart of age by name using plot kind bar and give it a title, and then draw a line chart of the height using plot kind line with a marker, letting pandas use data frame index for the x-axis. So let's start. If you don't have, we'll use the data from the exercise 1. If you don't have, you can just paste, copy this. You already know you have to import pandas and numpy, and let's continue. You want a bar chart, exactly, and we give a title. Which is age by height, no, by person. Exactly. We have the age by person. Exactly what it asked. Let's go for the line chart. Here we wanted the kind will be line, the title height, and the marker. Let's put it a different one. Exactly. And this is the height plot by a line chart with the circles, the marker, and the height as the title. And this was for the first one. So there we have the answers to this exercise. Let's go for the next one. Exercise 12. The group by method. Group by splits data into groups, applies a function, and combines the results. It's actually one of the most powerful pandas features. Requirements. Let's create a data frame with a team column and a points column. We have right here. Okay, you can go ahead and copy this and do this. We group the data by team A and by team B. This produces a group by object, not a data frame. Then we compute and print the mean points per team. So first create the data frame, and then let's apply group by. Exactly by team. We do this, and then we calculate the average. This is already grouped right here, and we calculate just the average. Okay, for team B, team A, the average number of points was 11.7, and for our team B, 22.5. So group by method. Let's go to the next exercise. Exercise 13, iterating over groups. You can loop through the groups of a group by object created in exercise 12 and process them individually. So let's reuse the grouped object from exercise 12. This was from exercise 12. This was also created in exercise 12. And now let's loop over that grouped object. And for each group, let's print team name and team rows. Okay. For team name, and we loop over both items, team data in group exactly. Let's print that. You can print the team name, and let's print also the team data. That's it. This loop will already work. Team name and the points for each team now grouped by. If this was a really large data set, it was really useful to divide the points by team. That's it, exercise 13. Let's go to the next one. Exercise 14, pivot tables. Pivot tables reorganize data for summary analysis, much like pivot tables in Excel. What we are going to do, build a pivot table from the team's data frame that we created. This run right here. With team as the index, points as the values, and aggregating function, the sum of these points. And print a pivot table. Let's do this. Here we'll just keep the values, the points, aggregating function, the sum, and print. Okay, see, we have the number of points, the sum of points for team A and team B. That's it. Let's go to the next exercise. Exercise 15, custom aggregation. We will use this function to apply several aggregation functions at once. For this, we will reuse the grouped object from exercise 12. Requirements. On the points column of the grouped object, we will apply multiple functions, sum, mean, and max with the aggregate function, and print the resulting statistics per team. Let's see. So we have the same data frame, the grouped object created by the group by in exercise 12, and now let's aggregate several statistics. the grouped object, go to the points, and use this to aggregate several statistics. And it will be np sum, it can be np min, and np max. It should be this. Okay, and that's it. So from the grouped object, we went to the points and aggregated several statistics. By team, we have the sum of the points, the mean, and the max for each team. That's it for custom aggregation exercise 15. We have two more couple of exercises. Let's go now to the end. Thank you. Let's go. Final exercise, exercise 16, putting it all together. We will combine filtering, grouping, and plotting into a single workflow. Requirements. First, create a data frame with name, age, and height for 5 people. Then filter and print the people older than 25. We will add an age group column where we will separate people under 30 versus people over 30. Let's print the average age per group using the group by method, and then draw a bar chart of the ages by name, setting figure size with fixed size. Let's start. Import the libraries that we need, and then create the people data frame and print it. Okay, go ahead and create this data frame. Let's advance while you do that, and let's print within the people dataset. Let's select the people with ages over 25. That's it. Okay, which were David, Martha, and Sophie, age over 25, and their height, all their data. Second step, we go to people, create age group. And within this age group, we separate people under 30. For those that have age under 30, else we will have people with 30 and over for age in people age. Okay, that's it, the first step. Second step, we want to obtain the mean for these two groups. Let's go to the height by age. Is it correct? Use the group by method. For the age group, within the age group we select the height, and for the height we calculate the average, and then in the end we print the height by age. That's it. Average height for people 30 and over 1.723, under 30 1.64 with floating point numbers. Last, let's create a bar chart for the people plot. X will be name, that was the requirement. Y will be the age. The kind will be a bar plot. Let's add a title. exactly. And let's increase a little bit the figure size with fixed size. Let's give it not so large, 84 for example. And let's create this. Okay, there we have a bar chart using plot from matplotlib that we learned. And that's it. This is the last exercise. Thank you very much. Hope you enjoyed. You learned pandas for data analysis. If you liked, click the like button, subscribe, and thank you very much. See you on the next course.